It's Algebra 2 lesson 80.5 doing properties of logarithms, beginning on page 493. We have something that looks like things we've done already, especially this first box. It says let b, u, and v be positive numbers and b not be the number 1, because nothing would change if it were the number 1. Product property says that log base b of u times v. You add the two. Remember, multiplication goes with addition and division goes with subtraction. So it'll be log base b of u plus log base b of v. You could separate any number, and we'll look at what that means in a second when we're using numbers. Same thing with quotients. Division goes with subtraction. Log base b of u minus log base b of v. And again, this is when the bases are the same, or you're separating two things that are connected to the same log with a base. And then the power property says that log base b of u to the n power is the same thing as moving that n, just taking it and bringing it to the front. N times the log base b of u. And again, let's look at that with some numbers mixed in and make a little bit better sense. In the instructions, it tells you to use log base 3 of 4 is approximately equal to 1.262, and log base 3 of 5 is approximately 1.465. If you punch those into your calculators, you'll get those numbers. And again, it's approximating because it's only giving you 3 digits after the decimal. It tells you to approximate this following number. Log base 3 of 4 over 5. Remember, division pairs with subtraction. So you're going to separate it first into the log base 3 of 4 minus the log base 3 of 5. Again, changing or separating the division of 4 and 5 into having the same log with the same base, but subtracting 4 and 5. Again, the bases tell us that they're approximately 1.262 and 1.465. That's where those numbers come from. Log base 3 of 4 and log base 3 of 5. And then when you subtract those numbers, even though they're long numbers to subtract, it's a simple calculation. It gives you an approximate value of negative 0.203. If you need to, stack them on top of each other where you can solve them or where you can simplify them. The second one says log base 3 of 20. Okay, what we want to do is we want to change it. We want to change 20 into something that we know, some kind of basis that we know. Again, in the instructions, it gave us log base 3 of 4 and log base 3 of 5. We know that if we multiply 4 and 5, we can get to the number 20. So this change right here, and again, this is going back to what we talked about last week, this number 20 more specifically is becoming 4 times 5. And the only reason it's becoming 4 times 5 is because we have approximations for 4 and 5 up top. So we're using what we know to figure out what we don't know. So log base 3 of 4 times 5. And again, multiplication goes with addition when you separate them. Notice on this next step, we have log base 3 written twice. You separate it to log base 3 of 4 plus log base 3 of 5. And again, we know what those approximations are. That's 1.262 plus 1.465. Again, those numbers come directly from the directions. That's where we get those long digit decimal numbers. And when you put them together, you get 2.727. As we look at C, it says log base 3 of 16. Can we multiply 4 times 5 and get 16? No. We know 4 times 5 is 20. What can we do to the number 4 to get to the number 16? We can square it because we don't want to multiply it times itself in this case. So we want to show what happens when you square it. Log base, so now the number 16 becomes 4 to the second power. And again, it would be acceptable to write log base 3 of 4 times 4. That would be the same thing since we know what log base 3 of 4 is. but it's simpler and it's quicker to write it as 4 squared. Watch what happens when we write it as 4 squared. It becomes 2, and again, this 2 goes up front, 2 times log base 3 of 4. And again, we know what log base 3 of 4 is. It's approximately 1.262. So it's 2 times 1.262. And again, when you approximate that, when you multiply 2 times 1.262, you get about 2.524. On the back, let's do this one. Use these approximations that are in the directions. It says use log base 9 of 5 is approximately 0.732, and log base 9 of 11 is approximately 1.091. To approximate log base 9 of 5 over 11. Take about 1 minute on that. Okay, so we have log base 9 of 5 over 11. Separated first. Separated into log base 9 of 5 minus log base 9 of 11. Everybody see what I did there? All I did was took division and separated them, made them both log base 9, one of them a 5 minus 11. Then again, in the directions, we know that log base 9 of 5 is approximately 0.732 minus, we know log base 9 of 11 is approximately 1.091. So when we subtract these numbers, and again, calculators make this faster, but if you don't have one, you don't need one. You know they're opposite numbers, so you're going to subtract them. You do 11 minus 2 is 9. 12 minus 9 is 3. 6 minus 0 is 6. I did that wrong, excuse me. Stack them if you have to, the way you don't make that mistake I just did. Just like this. Again, 11 minus 2 is 9. 8 minus 3 is 5. And then 10 minus 3 is 7. So it'll be 0.359, but remember, 1.091 is the bigger absolute number, so this has to be negative 0.359. Let's do the same thing. Let's use the same approximations from log base 9 of 5 and log base 9 of 11 to do this one. Log base 9 of 55. Again, take 1 minute. Again, how can you change the base to have something that you know to simplify it? Again, we know what log base 9 of 5 is and log base 9 of 11. We know what each one of those is. So let's make the number 55 into something that we know. We could change it into log base 9 of 5 times 11. All we did was change that, 5 times 11. You might not have written that step. You might have gone right to the next step, changing division into, I'm sorry, remember multiplication is paired with addition. Just like for the first one, division was paired with subtraction. So you changed it to log base 9 of 5 plus log base 9 of 11. Log base 9 of 5 plus log base 9 of 11. Again, you know what log base 5 is. Base 9 of 5, it's 0.732. That's what it tells you to use. Plus log base 9 of 11 is 1.091. So in the last problem, we subtracted them. In this one, we're adding them together. So 1 plus 2 is 3. 9 plus 3 is 12. Carry 1. 7 plus 0 plus 1 is 8. So you have 1.823 is your approximated answer for that one. And the last one, let's use the same numbers, the same approximations, and let's solve or let's simplify for log base 9 of 25. Again, you have to use numbers that you know to solve for numbers that you don't know. So it says log base 9 of 25. All we know is what's written in these directions up here. All we can use is that stuff. Again, there's an infinite number of things, but this is what we're going to use according to the directions. We can make that number 25 into 5 times something. Okay, you can't multiply it times 2. You can't multiply it times 5. You could multiply it times 5, but it's easier to change it into log base 9 of 5 squared. That's the same thing. Again, 25 is 5 squared. And again, when you have an exponent after a logarithm like that, it moves up front. So the 2 goes here. And it becomes 2 times the log base 9 of 5. And again, we know what log base 9 of 5 is. In the directions, it tells us log base 9 of 5 is that. So it's 2 times 0.732. So if you looked at that problem and you immediately thought, I just got to multiply that times 2, you were probably right. Because when you multiply 2 times that, you get 1.464. It's your simplified version. 1.464. And we'll do the rest of these tomorrow.